everybody, and welcome to The Professors. And we're the professors from McMurry University. I'm Paul Fabrizio. I'm a professor of political science. And to my right is...
Christopher Bartlett. I am standing in for Dr. Frazier today.
And Dr. Frazier is off, but Chris, you are a recent graduate of...
McMurry University.
That's
yes,
right.
sir.
That's right.
Yes,
So
sir.
Are you a professor yet?
No, not yet.
Okay, so you're just pretending to be a professor?
Yes, sir.
Okay, very good.
I guess it is the professors. Okay.
Yeah, so we had to find another
I was thinking it was going
professor.
to be just the professor.
No,
it is
because
the
we
professors.
have, see the guy in the blue over there?
Yeah.
That is a professor.
Nice.
Yeah, scary,
Nice.
scary. And we're going to talk about a subject that is a little frightening to me because it involves math.
Yeah.
Okay? But we'll get to you in just a second, sir.
Sure.
Over in the far corner over there is Scott the engineer, and he understands some math, so he'll be helpful in this program too.
Oh, yeah, I'm going to be a wealth of knowledge, yeah. And I have to say, we're from Abilene, Texas, that I learned in the last show, so.
Yeah, it's amazing.
Yeah, right.
You finally learned where we were. Yes, we're from McMurry University in beautiful Abilene, Texas, on a hot May day where the temperature outside is supposed to be 103 degrees.
And it's not even summer yet.
And it's not even summer yet. Summer doesn't start for another 20-something days. Anyway, our guest today, and we're delighted to be here, we're delighted you're here, and of course we're delighted to be here too, is Dr. Wayne Keith. Dr. Keith, welcome to the show.
Thanks.
And you are a professor of physics?
Physics and astronomy.
Okay.
Yeah.
Now, so many things come to mind when I think about physics and astronomy. First of all, aren't they two totally different things? Do you have a PhD in both?
My PhD is actually in space physics. That's what it says in my diploma.
Okay. So that implies that there's other kinds of physics besides space physics.
Right. So space physics is a slightly different discipline, for example, than astrophysics.
Astrophysics is?
Astrophysics is the study of stars and their physical characteristics, whereas space physics is mostly the solar system and looking at things that you can fly to with robotic spacecraft. The way we used to explain it when I was at Rice and I was in the Department of Space Physics and Astronomy was, well, if you can fly a spacecraft to it, even a robotic spacecraft, it's space physics. But if you look at it through a telescope, it's astronomy. And that's a pretty rough way to delineate, but that more or less works.
But then there's just physics.
Right.
And that's something totally different.
Well, yeah, I would say it's probably more fair to say that both space physics and astrophysics and astronomy and all those things are subsets of physics.
And so what's physics?
So physics is just the study of the physical world. And so in that sense, it's basic to almost every other scientific discipline. In fact, there's a cartoon, I don't know if I can remember it completely, but that starts out somebody saying, well, sociology is just applied biology. And the next guy says, well, biology is just applied chemistry. And that guy says, well, chemistry is just applied physics. And then the last guy's way over to the side, and he's math. And he's like, hey, what are you guys doing over there? Because the implication is that everything's applied math, but that it's so far removed from the other sciences that it's like there's this big space. So it was only funny to people like me.
And I'm sure it was very funny to you.
It was very funny.
Okay,
so
the rest of us
I've
just aren't.
learned space physics today, so
it was like space physics is
physics.
different than astrophysics.
Yeah.
Who would have known? Yeah.
Who would have known? Well, obviously,
I didn't, but
and at Rice University they did.
yeah.
We've got to explore this a little bit more, but first, tell us a little bit about yourself. Where are you from? Where'd you go to school? That sort of stuff.
Okay, I grew up in Stephenville, Texas, which is a little less than 2 hours from here. It's the home of Tarleton State University. So I graduated Stephenville High School. I went to Tarleton State University as a physics major. And
what did you want to do as a physics major at that time? Were you interested in space?
Yeah, I was the kid who said he wanted to be an astronaut, and so I've always had an interest in space. I don't know if you can blame it on Star Wars or Star Trek or any of those kind of things they were coming out when I was a kid, but it was always something that I was very interested in. I had little, model Apollo rockets and stuff, and space shuttles. Once they started doing those, I had little model space shuttles and everything.
Did you see the new Han Solo movie?
I have. I saw it opening night.
And
I liked it.
Okay.
Me too. Me too.
Okay.
Okay, I haven't seen it yet, and I hope to. And so I'm just curious, if, from your
Yeah, I don't-
perspective,
There
if
hasn't
it
been
was
any
good.
Star Wars movies that I disliked. Some I like better than others, obviously.
Okay.
But it was I would say middle of the pack, maybe a little bit above average. So
Okay.
it was
Boy,
good.
talk about veering off the subject.
That's all right.
That was something.
It's all right.
Scott likes it when I veer off the subject. Over there. So we've got about 5 minutes before our next break. So let's go back to, you were at Tarleton,
Right.
and you decided you really wanted to study space.
Right. So I started out, I wanted to be, I go into aerospace engineering. So I thought, well, I didn't think with my flat feet and all that sort of thing that maybe I would be able to be an astronaut. So I thought, well, if I can't fly them, I'll design them. And so I started out thinking I wanted to be an aerospace engineer. And when I first started at Tarleton, one of the head of the physics department there, Jimmy McCoy, who's still there,
Mhm.
he sat me down and said, do you want to be the guy who does what people tell them to do, or you want to be the guy who's like the big idea guy? And of course I said, I want to be the big idea guy. And he said, well, you should go into physics instead of engineering, because the physicists are the ones who tell the engineers what to build. And that's an oversimplification, of course.
So the engineers actually do the building.
But the engineers do the work, but the physicists are come up with the ideas about what to build, basically. That's what he was
Okay.
trying to say. And
My dad was an engineer
And I
in
don't-
the aerospace industry.
Okay, well, there you go. So, and I don't know how accurate of characterization that really is, but it was enough to get me to switch from pre-engineering to physics, which is probably for the best, because their pre-engineering program at the time was only a 2-year program. Then you had to transfer to A&M College Station. And I don't regret spending all 4 years at Tarleton and getting a physics degree. So it was not bad advice. I'm not sure if the way he said it to me was 100% accurate, but it was certainly not bad advice. And of course, he was recruiting for his department.
Mhm. Right. So you decided to focus on the space and to be the big idea guy, and then you can't do that with just a bachelor's degree, I would imagine.
Right. So people, when I was an undergraduate at Tarleton, and I told people I was a physics major, they said, "Oh, what do you do with a physics major?" I said, "Well, you go to grad school. That's really all it's good for."
Yeah,
So when I was a senior at Tarleton, I started applying to graduate schools. I was really interested in staying in Texas if I could,
Mhm.
being a native Texan. I was born in Fort Worth, but I grew up in Stephenville. So there aren't a lot of choices for really high-end, really good space physics and astronomy programs in tech. There's the big state schools, of course, UT and A&M, and then there's Rice,
Mhm.
which Rice is typically ranked in the top 3 or 4 in the nation for space physics and astronomy. So that was my top choice.
And Rice is in Houston. It's
Rice-
right next to the Johnson Space Center.
That's right. That's right. In fact, the relationship between Rice and Johnson goes back to the beginning. I think they told me at the time that originally the land that Johnson's built on was originally Rice property, and they donated it for the Johnson Space Center. I don't remember all the details, but there was a really tight relationship. And when they actually brought me in to interview me as a potential graduate student there, one of the things that they did was they gave us a tour of Johnson, and the tour was hosted by an astronaut, which was pretty darn cool.
Oh,
And
so
and
they
the
didn't-
astronaut was a Rice graduate, so they all kind of tied together.
Oh, how
There's
was the
actually
astronaut?
been I can't remember her name at the moment, but I know that she's passed away now.
Mm.
But she was a space shuttle astronaut, and if I think about it for a minute, I could probably remember it.
Huh.
Not one of those things I prepped for.
Okay, so you went to Rice to study space
Mhm.
physics,
Space
astronomy,
space physics. I was really
Space
interested
physics.
at that time
So
in
solar
building
system.
things that went into space. And so
Okay.
I wanted to do something where I was building something that would go into space. And so space physics, you're more interested in satellites rather than telescopes, which, you build an instrument for a satellite, it goes into space. And so that's what I wanted to do in grad school. That's what I did end up doing in grad school.
You built something. That
Yeah, I
went
built
into
an
space.
built an instrument. Its acronym is Medusa, and I could probably remember that one. I think it's
Medusa.
Medusa, miniaturized electrostatic dual top hat spherical analyzer.
Woo! Very
Oh.
good.
Yeah, say that
What
fast
does
3
that
times.
do?
It measures electrons and ions that are in near Earth space. So mostly trapped electrons and ions that are trapped in the Earth's magnetic field.
So where is this Medusa now?
So Medusa was placed on a Swedish satellite called Astrid 2. And Astrid 2 was launched from Russia, from Plesetsk, Russia, into a polar orbit, which is what most scientific satellites are in. And as far as I know, it's still orbiting the Earth. It only worked for a few months, but once they lost contact with it, it stayed in orbit because it's not like it's just going to automatically fall out of the sky. So as far as I know, it's still there, but it's no
When
longer
did it
functioning.
launch?
I want to say it was 97.
Hmm.
I know that the second one we did was we built a second instrument called Medusa 2, and we put it on a different Swedish satellite called Moonen, which was a nano satellite. It was literally this big. In fact, if you go by the physics department at McMurry, I have a full-scale model of it in one of our display cabinets. It's a little styrofoam thing about this big, and that one was launched from Vandenberg Air Force Base in California. And I remember when that one was launched because every day doing the launch prep, we'd go back to the hotel room and see who was try to see who was president, whether it was going to be Bush or Gore.
Oh,
So you know when that one
I
happened.
do. 2000. November, December 2000.
That's right.
Okay, we're going to take a break. When we come back, we want to talk a little bit about space. It's an interesting thing. We all look up at it.
Yeah,
So
very cool.
anyway, we will be back in just a second with Dr. Wayne Keith.
When you support McWhinney History Education Group, you also support the many young workers who operate and maintain the company's digital operations. These are dedicated university students who handle many things such as filming, recording, and editing content for McWhinney, as well as cultivate the layout and structure of McWhinney's various websites, including its associated channel on YouTube. We are a nonprofit organization that exists from donations from interested persons and history enthusiasts alike. Donations enable our students to obtain a higher education, job training, and career bolstering skills. If you would like to donate, please visit us at www.mcwhinney.org and click on our About Us tab to learn more.
And we're back, and this is Paul Fabrizio of the Professors here from McMurry University in beautiful Abilene, Texas. I think we should go around the room one more time and introduce everybody. So,
Okay, Christopher Bartlett,
but who are you?
McMurry graduate.
Okay,
Yeah,
and filling in for
Don Fraser.
and doing a great job.
Yeah, I mean, I try.
Okay, and he's got questions that he wants to ask our guest. So let's introduce our guest.
My name is Wayne Keith, and I'm professor of physics and astronomy here at McMurry. Been here since 2006.
Okay,
So-
very good. And off in the corner,
As always.
looking dapper.
Oh, thank you. I appreciate
welcome.
that. You look well today, too.
Thank you very
Yeah.
much.
Yes,
It's Scott the engineer.
it's me.
It's him. Okay, so we're talking about, well, first of all, we all got a big surprise when we discovered there's different kinds of physics.
Yeah.
There's space and astrophysics, and we're going to focus.
They're just different
with
specialties. Yeah.
different specialties. We're going to focus with Dr. Keith on basically the solar system
Mhm.
as opposed to stuff beyond that. So But Chris has some questions he wants to ask. So please go ahead, Chris.
Okay, fine. My first question is, noted astrophysicist Elton John once said that Mars ain't the kind of place to raise a kid. In fact, it's cold as hell, and there'll be no one there to raise them if you didn't. So what is the possibility of life starting on Mars?
You're talking about life being there now or life being
Or
there in the
just
past?
Being there now, like if we landed people.
Well, if we landed people there, there would be life there. No, but as
Could it
far
be
as
sustained, I
as far
guess?
as I think, well, I mean, we can sustain life on the moon because we did that in the 60s and 70s, and so in that sense, I think technologically we do have the technology to keep people alive long term on Mars. I think there's a lot of details to be worked out, but the broad strokes of do we know how to do this? I think the answer is yes, we do know how to do that.
Nice.
But it's still not a good place to raise your kids, probably, because
Yeah.
you're gonna be, probably most likely in order to protect yourself from radiation and other hazards, you would want to build your habitat underground, and so you're going to be living with probably very no windows and only limited time allowed on the surface to limit your radiation exposure. So I don't know about you, but that seems like kind of a weird
sounds
way to
pretty
raise your
well.
kids.
You want to be
Well,
away from the
we
radiation.
began this conversation by you wanting to be an astronaut.
Yes.
If the opportunity came along to go to Mars, would you do it? Realizing you're now married with kids,
Right.
right?
I think before kids, the answer would have been definitely yes, as long as my wife and I could both go.
Okay.
And I think we probably would have said yes. Now that we have kids, it's a little bit more complicated question, but I wouldn't outright say no. But I'd have to think about it. But as far as taking my kids with me, it would.
They would probably say yes.
They would probably say yes because they wouldn't realize what they were getting into. But certainly, I don't know that I would want to be on the first wave at this point. But if there was an established Mars colony and they were putting out a call for families to go move to Mars, I wouldn't say no right away. It would be something I'd have to think about.
And it's like a 2-year trip.
Yeah. With our current technology, it's about a 2-year
Trip.
journey. Yeah.
Now, I saw the movie Martian.
Now
with
the
Matt-
actual one-way part of it is not 2 years. It's when
Right.
they're talking round trip. That's
round
what they
trip.
say.
If
It's
you
about
want to
2
come
years.
back, I guess.
Well, presumably, but you never know. If they're taking families, it might be to set up a colony. I mean, Elon Musk
Ooh.
wants to colonize Mars permanently.
Well, he also wants to build tunnels underneath Los Angeles.
He's
and
got a
stuff
lot of
like that.
interesting ideas.
He
But
does.
he also wanted to build electric cars, and that's going pretty well for him. So
We'll see. Okay. Now, let me just go back. The movie Martian with Matt Damon, did you see that?
I did, yes.
Was that accurate in terms of how hard life was?
As a sci-fi aficionado, I can say that is the most scientifically accurate sci-fi movie I have ever seen.
Wow.
That's not to say it was perfect,
Yeah.
but it was the best. And they did a really good job. I've also read the book. After seeing the movie, I was so impressed with it. I read the book, and I've also read Andy Weir's newer book, Artemis, just because I'm so impressed with how much he does his homework as far as his scientific accuracy. And that's an author who really does his homework. And they strayed from the book a few places in the movie, but nothing too serious. In fact, probably the most serious scientific inaccuracy is absolutely necessary for the story. And that is the very beginning scene with the windstorm that causes him to be stranded in the first place. There's not anybody out there that hadn't seen it because it's spoilers. But
Go ahead,
if you
spoilers.
hadn't seen it by now, then you should just expect. So because the atmospheric density, the air density is so low on Mars, even gale force winds, you would hardly even feel them because there's just not that many molecules of air hitting you. And even though there are dust storms, it would never be so thick that you couldn't see more than a foot in front of your face. So there was a little bit of Hollywood in that initial scene setting up his being stranded on Mars because there's just not enough atmosphere. It's like 100th the pressure of Earth atmosphere. So there was no way that no matter how fast the wind was blowing, it could blow over that spaceship or it could blow him, away from their view. So that was Hollywood.
That's fascinating.
But again, it was totally necessary, right? Because how else
Yeah.
are you going to set
Yeah.
that up?
Yeah.
And so
An alien attack?
well, I can usually forgive scientific inaccuracies in movies if they're necessary to the plot, because it's like, okay, I'll give you that one. That kind of had to happen. But what really bothers me in sci-fi movies is when they get some science wrong and they didn't need to. They could have done it right, and it would have been just as good a movie. In some cases, a better movie if they had done it right.
Do you have any examples?
I do have an example.
Okay.
Gravity, which is another.
Which I thought was so stupid. I'm sorry. I just got to say, I thought it was a stupid movie.
Well, I did enjoy the movie. It wasn't my favorite movie, but I did enjoy the movie. And they got a lot of stuff right. Whenever they interacted with the technology, with the spaceships, whether it be Russian or Chinese or American, it was very realistic. People who know have even said that when she was on the Soyuz and she was pushing buttons, she was pushing the correct buttons at the correct time. They did a lot of things right. The orbital mechanics was totally wrong. But again, they kind of had to, because there's no way you can get from one of those orbits to an orbit of one of those other objects with just your backpack. But the part that bothered me the most, and it's been criticized by lots of people on the movie, was the scene where they're trying to grab onto the space station and they miss, and they're drifting away from the space station, and her leg gets caught up in some shroud line, and the George Clooney character they're tethered together, right? And he's further away. He's not caught up in the shroud lines, and he disconnects himself, right, and basically commits suicide, if you will. He sacrifices himself to save her. But the way he did it totally wouldn't have helped her, because he just lets go, and there was no tension on that line. And so there was already no force from him pulling on her. And so it was like this dramatic scene with this dramatic death, but it was totally unnecessary. But afterwards, thinking about it, I thought of a way that would have been not only scientifically more accurate, but also, I think, dramatically better. And that is, they should have pulled themselves together with the tether until they were touching, and then push off of each other after he's disconnected. And that would give him a high velocity away from the station and her a higher velocity towards the station, and which would have been very dramatic, because it'd be literally touching face to face. I'm going to push off you. No, don't do it. And then he pushes off her and basically pushes her to the station, and the equal and opposite reaction as he goes away from the station. That would have been such a dramatic scene, and they didn't do it. And what they did do was not only less dramatic, but it was scientifically wrong. So that's one of those moments where I really wish I'd been a consultant on that movie.
Is that another goal of yours, to be a consultant on?
Not per se, but I think it would be fun.
If the opportunity
arose, I think it would be a fun thing to do. Especially if I could do it part-time and still teach.
Okay.
But it's not like a life goal, but I think it would be a fun thing to do.
Okay, now we've got no time left. We're going to be back.
We'll be right back.
History has become one of the most fought-over battlegrounds in terms of shifting people's views and opinions about their country. In response to this, we have decided to launch a website called Go To History that will become your home for clear-eyed history content. Our objective is to put history out there, free of agendas, and allow you, the viewers, to decide what you believe and decide how to interpret this information. With experienced professors such as Dr. Don Frazier and Dr. Stephen Hardin teaching courses and creating agenda-free content for students and just plain history enthusiasts, the content of Go To History is vastly informative and unbiased.
Hey history people, it's Phil Collins here. I am just giving a shout out to a couple of guys that you're going to be hearing from. And they're good friends of mine, but they're also incredibly knowledgeable historians. Dr. Donald Frazier and Dr. Stephen Hardin. Both great friends of mine, both helped me out with my book on the Alamo. And two guys, if you don't know much about history, these are the first two guys you should go to. Okay, what they don't know isn't worth knowing. Don Frazier, Steve Hardin, I hope you enjoy their presentations.
My name is Ebony Williams, a history major at McMurry University, and I love the layout of the Go To website. I mean, it is singularly built from the ground up with user convenience in mind. Every study available is within a single courses tab, with each lesson having a single page for each of its individual videos, text, visuals, and quizzes, all at easy grasp. This is most definitely history made simple.
please log on to www.gotohistory.com.
And we're back, and this is Paul Fabrizio, the professor's here from McMurry University in beautiful Abilene, Texas. And we have as a guest Dr. Wayne Keith, professor of astronomy at McMurry University. And of course, asking questions now is recent graduate of McMurry University, Chris Bartlett.
Yeah.
And we do want to say that this whole show is put together by Scott the engineer, who does not get a last name. He's just known as Scott the engineer. So,
I think
Wait
that
a
should
lot
be.
for us.
I think
What
that
do you
should
want me
be
to
a the mystery of the show.
That's
What is
right.
his last name?
what is his last name?
Yeah.
Maybe every day we
Right.
should leave a clue.
I thought it was just the engineer.
Yeah, what would that be in another language? Like Scott Van Engineer or
Sounds
Scott
good to
the
me.
Engineer?
Yeah.
Or, I don't know. Anyway, so
The
Chris,
engineer.
okay, Chris, you had another question, and the last one involves singing Elton John songs.
Yeah.
That was a little weird. So
Okay, I won't do that again.
no, please go ahead, do what you want. You're a graduate, now you're an alum. The university depends on its alums. Go ahead.
Well, we were talking about two space movies that came out in the last few years, The Martian and Gravity. Another one that came out was Christopher Nolan's Interstellar. So how did that live up to your
Did it make any
expertise?
sense to you?
You know, kind of. I didn't. It was an all right movie.
Oh, it was a good movie.
I
A
didn't
I'm pretty.
see that
You know, I'm.
little weird.
It's pretty
It
good.
was weird. I did enjoy it.
I saw it twice to understand it.
There was one major part of it that really bothered me in the moment. I mean, there's certain things like the whole going into the gravity well of the event horizon of the black hole and stuff that you just kind of suspend your disbelief and assume that it's technology beyond our understanding, so you just kind of go along with it. But there was one part that really bothered me at the time when I was watching it. It really took me out of the movie. And it's the kind of thing that might not bother a lot of people, but it was their spaceship. Because if you remember, when they took off from Earth, they were in this big rocket. It was almost like a Saturn V scale
Yeah.
rocket with that little craft on the top of it, the little space shuttle looking thing on the top of it, right? So they needed that big rocket to get out of Earth's gravity well, right? And then they used that same little space shuttle craft to land on that water world, remember, that they went to first, and then took back off again. It was a whole other planet, presumably, similar in size to the Earth because they had gravity and everything. And yet they were that little tiny shuttle with whatever internal fuel tanks it had was able to get back out of the gravity well of that second planet without the big Saturn V on the bottom.
That's
Big
a good.
faux pas
That
here.
is-
Whoa.
So it's the kind of thing
No,
until
let
you
me-
think about it, it doesn't bother you. Once you realize that they did that, you're like, oh man, that is terrible. So
well,
Huh.
let me ask
Wow.
you this. When you see something like that, does it ruin the movie for you?
well, I don't like it when it takes me out of the moment. If it's so glaringly obvious to me that it takes me out of the moment, then that bothers. I don't like that about the movie because I don't want to be taken out of the moment. I want to suspend my disbelief and play along. And so a lot of the things, like the windstorm at the beginning of The Martian, until you really sit down and do the math, you don't really know whether or not that's plausible. So okay, we'll give them the benefit of the doubt. And The Martian is probably the only sci-fi movie I've ever watched that at the end of it I was like, I got nothing. And in fact, my brother specifically took me to see it. I don't know, it came out near Christmas. I don't remember.
I forget the year, but yeah.
But yeah, my brother, who's not a scientist, but he's a computer programmer, a very smart guy, and he's always asking me, what mistakes I have found in sci-fi movies. And so he had watched The Martian previously, and he didn't catch anything, and so he wanted to sort of test me and see if I caught anything that he didn't. And so at the end of the movie, he's like looking at me. And he goes, so what do you think? And I'm like, I've got nothing. I mean, in the moment, there was not a single thing that I went like, that's impossible. That can't happen. And so it was really an enjoyable experience for me to be able to go through the entire movie and not ever be pulled out of the movie by bad science.
Bad science.
That's
Bad
great.
science.
Wasn't
That's
that the
great.
name of a movie?
That was
Bad
weird
science?
science.
Weird
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 science. Oh, okay. Is your next question about movies?
No.
Can I ask another
Yeah,
question
go
about
ahead.
movies?
Go ahead. Yeah,
I mean,
go ahead.
this isn't what we meant to talk about,
But that's great.
It's all right.
I mean, this is great. So this 2018 is the 50th anniversary of 2001, the Stanley Kubrick.
Oh yeah, from 1968. That's
Yes.
right. That's right.
Yeah. So
Huh.
I assume you've seen 2001 by
Of
Stanley
course, of
Kubrick,
course,
a
yes.
Space Odyssey. Considered an awesome movie.
Considered very scientifically accurate.
What do you think about that as a real, honest to goodness space scientist, a rocket guy?
I think they did really well. Considering what they knew in 1968, I think Stanley Kubrick did as good a job as he could have done. One of the things that gets wrongly criticized about 2001, because people don't understand what would really happen, is there's a scene where the main character is trapped outside the David Bowman, I think, is
The actor.
well, that's the I think that's the
Oh,
character's name.
okay.
And so he's trapped outside the Discovery in his little pod, and Hal won't let him back in because Hal's going crazy.
Al.
Right?
Al.
Open the pod bay doors, Hal. Open the pod bay doors. Yeah. So that scene, the resolution of that scene was that he backs up the pod to an airlock, and opens his pod airlock and gets blown out of his pod into the open ship airlock, and then quickly closes the door, and he's like, but he survives. And people think, oh, well, he would have exploded, he would have died, he would have froze solid, all the other things that Hollywood does when you get exposed to the vacuum of space. But actually, 2001: A Space Odyssey got it right. That is plausible. You can survive a few seconds in space.
Really?
Yes.
Cool.
I didn't know that.
Huh.
Well,
I've always thought you couldn't.
Well, and that's
I thought you would explode or something like
So
that.
now we got that going for us. I mean,
Yeah, right.
next
yeah.
time I'm up there.
right. Well, it wouldn't be pleasant, but what actually would kill you first is suffocation, lack of oxygen. That's what kills you first.
So, and how quickly would it kill you?
About a minute.
Oh, okay, plenty of time.
Yeah.
Okay, and by the way, 2001: The Space Odyssey was written by Arthur C. Clarke, right? Or was based on a book that he wrote?
Well, my understanding is that the screenplay and the book were written simultaneously.
Okay.
That he was that Arthur C. Clarke was writing the book, and Stanley Kubrick and Arthur C. Clarke together were writing the screenplay, sort of all together simultaneously. Which is weird, considering in the book they don't even go to Jupiter; they go to Saturn.
Huh.
So there's some interesting differences between the book and the movie, considered they were basically written at the same time.
Right. And Arthur C. Clarke was a scientist, wasn't he?
I don't know exactly.
He was
what
a science
He was a science fiction author, but I think
but
he did
he-
have some scientific training. I don't know exactly
yeah,
how much.
he was known for his science.
Yeah, and he was known for
Yes.
writing very realistic and what they call hard science fiction. You know,
Okay.
where it's very realistic.
Okay. Now, since
there
we're on
again,
this, go ahead. Were you going to say something?
There, yeah. No, I have a question at some
Please.
point, but I mean, okay. So
We should make this a double episode.
I agree.
I know you don't have time, but,
But-
I know. We should.
So
can you come back?
Yeah. Let's
you
talk more
being in that
movies.
field and everything, and
Yeah.
we're talking about all the scientific stuff and the aliens and all that.
Okay.
Have we had? Did the aliens help us out at one time to where we came up on all this technology that got us into space and everything? Like some people
I don't
say?
think so. I mean, if I just give you the answer that I usually give my astronomy class, because this always comes up, is there life elsewhere in the universe? Almost certainly, because the universe is just so big. But is there life that's from elsewhere in the universe that's visited us here on Earth? I think that's pretty unlikely. And I think a lot of the things that people try to say that prove or somehow support the idea that we did, like, oh, well, we had to have help building the pyramids, the ancient Babylonians had to have help developing their mathematics. All those kind of things are actually kind of insulting towards humans. It's like, no, humans are clever. And we've always been this clever. I mean, we have more technology today than we had thousands of years ago.
Certainly,
But genetically, we were the same. And so, 2,000, 3,000 years ago, we were still genetically the same people. And so we had just the same amount of cleverness to figure things out. And I think it's actually kind of weirdly insulting to those ancient cultures to say they couldn't have done it without aliens.
Huh.
But
Sorry, didn't mean to insult anybody. I just wanted to know.
No. I let me change the question around.
Okay.
Instead of focusing on ancient cultures, how do you come down on the question of UFOs?
Okay.
For example, there's been this report recently that came out about Navy aviators
Hmm.
who were on an aircraft carrier who ran across things that they couldn't explain.
I think that there are real UFOs in the sense that there's unidentified flying objects, things in the sky that no one can explain. I don't think that just because you can't explain it doesn't necessarily mean it was aliens from another planet. I mean, to me, that's kind of a
Right.
logical leap. But yeah, certainly there are things out there that we don't understand. There could be atmospheric phenomenon. There could be technologies from other countries. There could be lots of things that we don't understand, or just something in your brain. It could be it's sort of an internal thing where radiation at high altitude makes you see flashes of light because there's literally cosmic rays going through your eyeballs. That's something they didn't know about in the early 60s, but now we understand when astronauts and high-flying aircraft pilots see flashes of light, it's cosmic rays interacting with the fluid in their eyeball. But so there could be lots of different ways to explain it. I think that automatically, just because you can't explain it right away, saying it was aliens from another planet, I don't really necessarily see that that's a reasonable place to go.
Okay, we're going to take a break, but real quickly before that, Star Wars, Star Trek, what's your favorite?
Star Wars.
Okay, with
Yes.
that, we'll be
All
back.
right.
Welcome to State House Press, a nonprofit publisher of quality books. State House Press and the McMurry Foundation Press are part of the Texas A&M University Press Consortium, which handles retail distribution for several small but distinguished publishers. Our entire list of offerings, with pictures, summaries, prices, and easy online ordering, is available in our section of the consortium website. State House Press is proud of its reputation for high standards of scholarship and readability. In addition to this, we at State House Press have recruited the talents of individuals such as Phil Collins on his book, The Alamo and Beyond. We release not only texana by contemporary authors, but reprints of classic accounts of Texas life and history otherwise inaccessible to the public. Our book list also incorporates the publications of the McMurry Foundation Press, specializing in the history of the Old South and the Civil War. We strive with our titles to make history accessible to as many readers as possible. To accomplish this task, we have recruited some of America's leading historians, as well as bright new scholars. We believe firmly in narrative history, in telling a good story, and in telling it well, without losing sight of the people who've made history and the events that changed a nation.
For questions or business inquiries, please visit the Texas Book Consortium at www.tamupress.com.
And we're back. And this is Paul Fabrizio, the professors from McMurry University here. And of course, Chris Bartlett.
How's it going?
I don't know. How is it going?
Pretty good.
Okay. And Chris is going to ask the next question of our guest, Dr. Wayne Keith of the Department of Physics and Astronomy at McMurry University. And of course, there's Scott, the engineer.
Don't worry about me. Ask me.
Yeah, don't worry. So Chris,
All right, what do you
please
got?
go ahead.
Okay, January 28th, 1986. Where were you?
I was homesick that day.
Mm-hmm.
So I was in junior high, I want to say, 6th grade, maybe 6th or 7th grade. But yeah, I was homesick. I hadn't had the TV on. My dad came home from lunch. He was a professor of biology at Tarleton, and he came home for lunch, and he was like, "Did you hear about the space shuttle?" And I was like, what about the space shuttle? Because I was homesick, I hadn't paid attention. So he turns on the TV, and of course, every channel was talking about the Challenger explosion, and we watched it for the rest of the day, and that's pretty much all anybody talked about for days after that.
Mm-hmm.
So a lot of people who were in school at the time watched it live, because with the school teacher on board, they'd wheeled in TVs to a lot of classrooms, and a lot of kids had watched it live. But I don't know if my class did that or not, because I wasn't there. I was homesick that day.
Okay, very good. Any other questions for our guest?
Same question. February 1st, 2003. Where were you?
So for the Columbia explosion,
Right.
I was. So you, I didn't know what you were going to tell. So for the Columbia explosion, I was living in San Antonio. I was doing my first postdoc at Southwest Research Institute, and I think I don't remember what day of the week it was, but I was still in bed, and my sister-in-law called. They also lived in San Antonio, and she called, and we didn't pick up the phone, so she left a message. Of course, you could hear it on the answer machine as she was leaving the message, and she says, "I just saw that the space shuttle blew up." And I remember just rocketing out of bed. We had a waterbed at the time, so it probably threw my wife onto the floor. Rocketing out of bed and like going into the living room and turning on the TV to watch the coverage. And of course, at the time, it was still kind of a developing story, because they weren't really sure yet. It was overdue in Florida. They'd lost communication. They didn't know what was going on, and then the home video started coming in of debris in the sky, and that's
Over Texas.
Over Texas. It was over Dallas area, and so it was sort of this developing story. But of course, once I saw the debris, it was like, oh yeah, it's done. It's done. It's gone.
A lot of that debris actually ended up in Toledo Bend Reservoir, and there's still pieces that they think are still
there.
Yeah. I remember some of the heavier pieces, like the main engines, made it to Louisiana.
Yeah.
I think, and ended up in lakes or marshes or something there. But I seriously considered I was in San Antonio at the time, working as a postdoc. I seriously considered taking a week or two off and joining the recovery effort to try to pick up pieces.
Yeah, I was
wondering. I wish I had now. I ended up not doing it for whatever reason. I talked myself out of doing it. But in retrospect, I wish I had tried harder to do that. I think it would have been, one of those life-changing experiences.
Well, if it makes you feel any better, 40% of the shuttle was actually recovered. Now, obviously, some of that burned up.
Mm-hmm.
The westernmost recovered piece of recovery was near Littlefield, Texas, and it started breaking up like over Las Vegas, Nevada. So
yeah, I think you're right.
Yeah,
right after they hit the West Coast.
Yeah, so there's all that area that still hasn't been discovered.
People
so
don't...
there's still possibly pieces out there.
So you're saying that maybe I can still go do it? Okay, it's not too late.
Yeah.
All right.
It's 15 years, but still, maybe some pieces out.
Maybe a few pieces.
Chris, I'm curious. Is this something you're interested in?
A little bit, yeah.
Yeah, because you knew
a lot.
You knew both dates.
Yes. Yeah.
Of the two shuttles that blew up.
Yeah.
How come?
The space race has always just interested me. I don't really know why, but it's always interested me, and I know little facts like that. So
I don't know that I could have stated the dates. I would have been able to say January '86 and February 03, but I couldn't have told you the exact dates, most likely.
And you're too young then to remember Apollo 1.
Right. But it was
which burned up.
It was also in January, I believe.
Yes, January 20.
The day before. Yeah.
27th. 27th?
Yeah.
Okay. And what year?
67.
67. I would have guessed 67.
My brother was born the day before.
Really?
Huh.
Wow. I would have been a spry. What day did you say it was?
January 27th.
Oh, I was 21 days old.
Oh, okay.
I actually have been to the pad.
I was 10.
I have been to the pad where Apollo 1 fire happened, and there's some nice benches dedicated to the three astronauts. It's a very solemn place, and I think everybody should go there at some point.
Now, let me just ask if I can cut in.
No, yeah, go ahead.
Because you grew up interested in being an astronaut.
Sure.
You still have an interest in it. It strikes me as a very dangerous profession.
It's relatively dangerous. Yeah. I don't know how it stacks up against, say, being a firefighter. There's certainly other professions out there that are also very dangerous. But, it's one of those kind of things where you don't really think about how dangerous it is. You just think about how awesome it would be, you know? And I'm sure the people who were on the shuttle right before they blew up, or the Apollo 1 astronauts right before the fire, they weren't thinking about, man, this sure is dangerous. They were thinking, man, I'm having the time of my life. This is so awesome. You know, so I don't know. I think it would be worth it.
Is there an acceptable level of risk that we should accept from our space program? And I bring this up because I think it's Elon Musk who's made some comments that some people said may have been a little bit crass about the value of human life. In other words, we need to go. We need to get into space, and people might die.
I think it's, as a general rule, I think it's pretty safe to say that we as a society have become more risk averse as our world has become safer, you know? And so things that, you know, the kind of risks that my generation and your generation took were, you know, riding your bicycle to school and that sort of thing, you know, walking yourself to the playground, that were considered acceptable, you know, in the 60s and 70s, or you can get arrested these days, you know, for some of those same activities. And so as a society, I think we're definitely more risk averse. I don't know how that translates to certain dangerous jobs like firefighters and astronauts, but obviously I think it's reasonable to think that we should make things as safe as we reasonably can. And one of the reasons why I was okay with them closing down the space shuttle program, even though it was so awesome in so many ways, is it really wasn't as safe as it should have been. A lot of the original design ideas for safety were lost along the way. You know, if you remember that tower that was on top of the Apollo capsule, that was designed so if the ship blew up, if the rocket blew up, that was supposed to pull the capsule free from the explosion and then come down on parachutes. They never actually had to do it, but that was the idea. The original space shuttle Columbia, during its first few missions, had 2 astronauts and they had ejection seats. But once they started putting more than 2 astronauts on it, there was no way to eject.
So the rest didn't have ejection seats.
Right, so they took out those 2 because it wasn't fair to have 2 people have ejection seats and everybody else just be left behind.
Yeah.
And so they took out the ejection seats completely.
Okay, unfortunately, we are running out of time.
Do you want to come back?
I would love to come back.
This is awesome. I love talking about this.
I could do this all day.
Dr. Wayne Keith at McMurry University, thanks very much. We're out of here. Class dismissed.